In this video I wanted to document the installation and use of the Carb Cheater on my 1960 Falcon. Over the past winter I replaced the 1966 200Six with a rebuilt engine from a 1983 Fairmont. While the motor was out, I welded O2 bungs in both exhaust pipes a few inches past the collectors. The plan was to eventually install a Bluetooth O2 sensor that I could use to get the carburetor tuned with. On the new motor I used a Weber 3838 2-barrel carburetor. It runs great, maybe a little on the rich side, with no flat spots or lugging. After a few hundred miles, we took it on a 950-mile trip to Tennessee and back where it averaged 22.25 miles per gallon. Before I got around to purchasing an O2 sensor I ran across the Carb Cheater product that was a Bluetooth O2, and had the ability to do some self-correction of the air-fuel ratio. It utilizes data from the O2 sensor, manifold vacuum and RPM to determine load and air-fuel ratio. All for just a few dollars more than the Bluetooth O2 sensor I had planned on buying. The Carb Cheater guys make a spacer with the correct vacuum connections for a standard 4-barrel carb, but not this little Weber. I ended up buying a flange/spacer on eBay as a starting point. First I drilled a 21/64" hole for the vacuum fitting, down the middle that ended between the two barrels. Then two 3/16" holes were drilled from each barrel at an upward angle to connect up to the larger previously drilled hole. I then tapped the hole for a 1/4" pipe threads and added the 3/8" 90-degree fitting to the spacer, also had to drill out the 4 mounting holes for the 5/16" studs. The control box was mounted on the front right apron and the vacuum sensor/control valve was mounted behind the shock tower on the right side of the car. Vacuum lines were routed from the spacer for the control valve, and from the manifold for the vacuum sensor. Wiring was really simple. My car has a Duraspark distributor and the MSD Street Fire box and coil. The harness supplied with the Carb Cheater had more than enough wire to make all the connections. After installing the app on my phone, I went out for a test drive with the auto tune turned off, which confirmed my suspicions that the carb was on the rich side. The steady cruise air-fuel ratio was close to 13.2. Moderate acceleration air-fuel ratio was around 12.4. With auto-tune on, and at a steady cruise, the control valve was spending a lot of time at 100% open, and couldn't quite get to the 14.7 air-fuel ratio. Pretty sure changing to a little smaller main jet will put it in a range where the Carb Cheater will have better control. The original main jets were 145. Original air correctors were 170s. And the original idle jets were 55s. It seemed like the best way to tune the carb was to buy a high-altitude jet kit on eBay for the Weber 3838s. This way I would have an assortment to tune with. For the idle jets we went from the 55 to 50s, also 5,000 smaller on the main jets from 145 to 140. And finally on the air correctors we went from 170 to 190. The carb does not have to be removed from the car to make these changes. The little E-clip on the choke arm is probably the trickiest thing to deal with. The idle jets are accessed externally, the air correctors are up by the squirters, and the main jets are in the bottom of the fuel bowl. After making the jetting changes, it now cruises with an air-fuel ratio around 14.5 with the control valve averaging 60% open. The idle is set for a target RPM of 700, at a 13.5 air-fuel ratio, plus or minus 0.5. Overall, I am very pleased with how the car is performing with the Carb Cheater installed and auto-tune on. We expect to see an increase in fuel economy as well as spark plug and engine oil life.